Alright guys, today we are looking at how to tell whether a quadrilateral is a parallelogram or not. So you need to know these theorems. They're the conditions for parallelogram theorems. And here's what you need to know. In a quadrilateral, meaning a shape with four sides, if any of these things are true, then the quadrilateral is a parallelogram. Note that you only need to verify one of these things. Okay, so either both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, the diagonals bisect each other, or one pair of opposite sides is both congruent and parallel. That's one pair, okay? Let's look at an example. It says determine whether the quadrilateral is a parallelogram, justify your answer. So I see that I have one pair of opposite sides congruent. However, this first one says both pairs of opposite sides have to be congruent. I do have this other one that says one pair of opposite sides both congruent and parallel. Let's look at these angles that they gave us, 100 degrees and 80 degrees. Looking at those angle measures, I know that those add up to 180. And if I look at this transversal, it tells me that these are consecutive interior angles, and I know whenever consecutive interior angles are supplementary, that creates parallel lines. So now that I have one pair of opposite sides, both congruent and parallel, I can say yes, FGHJ is a parallelogram because one pair of opposite sides is both congruent and parallel. Feel free to use abbreviations on this. Okay, there are two practice problems for you to try. Here are the correct answers. Next, we'll do this one. It says the diagram shows a side view of the tackle box at the left. In the diagram, PQ equals RS, let's label that, and PR equals QS. Explain why the upper and middle trays remain parallel no matter to what height the trays are raised or lowered. So if we notice here, these are the upper and lower trays. PQSR is a parallelogram because it has two pairs of sides, two pairs of opposite sides, congruent. In a parallelogram, the definition of a parallelogram is that the opposite sides are always parallel. So that means that PQ always has to be parallel to RS. Let's do another example together. This is finding values. It says FK equals 3x minus 1, KG equals 4y plus 3, JK equals 6y minus 2, and KH equals 2x plus 3. Find x and y so that the quadrilateral is a parallelogram. In order for this to be a parallelogram, the diagonals must bisect each other. So in order for this to be a parallelogram, JK must be equal to KG, and FK must be equal to KH. So I get the pair of equations. JK is 6y minus 2, KG is 4y plus 3. I can solve that on its own. Subtract 4y on both sides, add 2 on both sides. Next, divide both sides by 2. On the other pair of equations or segments, I get 3x minus 1 equals 2x plus 3. Subtract 2x on both sides, add 1 on both sides, and I get x equals 4. Alright, there's two practice problems for you. Here are the correct answers. And finally, I want you to reflect on this question. If two parallelograms have four congruent corresponding angles, are the parallelograms always, sometimes, or never congruent? Justify your answer.